Welcome to this talk on Dapr in practice. First, a quick poll. How many of you have heard of Dapr before? Cool. Yeah, nice. My name is Marc Klefter. My LinkedIn bio currently says that I help organizations become event-driven. So that means that I support cloud-native app development efforts with a specific emphasis on event-driven principles, practices, and patterns, which also explains my interest in Dapr. Dapr stands for Distributed Application Runtime. It's an open source CNCF project aimed at developing, as the name implies, distributed applications. So we're going to explore what that means and what Dapr is in this talk, but I named it in practice for a reason. And that's because I want you to be aware and leave this talk being aware of the many practical considerations that go into adopting this technology, should you choose that path. Because it's not a panacea for all your application needs, as we'll see. So let's begin investigating Dapr by setting the stage a little bit. So we are working with distributed applications, or want to develop them. So we'll use the popular term loosely coupled application services that are distinct processes communicating synchronously or asynchronously. We're assuming a cloud-native environment where we package, deploy, and run these application services. Our platform of choice will be Kubernetes. That's not a bad assumption to make because I believe upwards of 90% of current Dapr deployments are on Kubernetes. You can run Dapr in VMs, on-prem, I believe in serverless now, but we'll be confined to Kubernetes for now. Now, our application services utilize directly or indirectly certain common capabilities. Some of these are provided by the platform, Kubernetes itself, like service discovery, scaling out. Some are more of a cross-cutting nature, for access control, resiliency, observability. You can find these in a service mesh typically. And then you have capabilities closely sort of related to your application service that they need. And you utilize commonly cloud vendor services for that, for messaging, for state management. There's a book that is a couple of years old, still a very good read, that summarizes these capabilities in the form of microservices patterns for communication, state, and workflow. Again, you use cloud vendor services to implement these capabilities. But everything beyond what the platform provides, that's where you will find Dapr entering the picture. And that's where we're going to focus on. So, how many of you use PubSub? Or have used? If there's a single hand that doesn't go up, I'm going to question your profession. But I assume everyone has at least heard of, seen it, maybe even implemented PubSub. So let's start with messaging and how you would implement messaging PubSub if you integrate directly with a cloud vendor service. So hopefully you can see that this is a bit of JavaScript code in Node.js. And this application service needs to publish a message to AWS SNS, to a certain topic, to be subscribed to by other application services that use SQS to receive them. We are incorporating this dependency, a client library, directly in our code. We use a certain version of this library, we import it into our code, we create a client, configure it with, in this case, a specific region that we're in, running our application, and then we publish the message to a topic according to this SDK's declared API. Very common to see this, but there are a number of issues related to this setup. The most obvious one is, of course, that you are tying your application to a particular client or driver version. You need to make sure that the SDK version you're using matches the functionality or feature set of the specific resource or cloud vendor service you're using. Otherwise, you might get into trouble. Also, obviously, you're tied to a specific infrastructure, in this case, AWS, SNS, and SQS. With a client library, you sort of buy into the way you configure your client, the resiliency features it supports underneath, retries, for example, and how you observe the publishing of the messaging going on. And of course, security aspects. You need credentials. When you try this out locally, you have credentials set in a certain way. When you run it productions, you might have something else in place. So, is this really what we as application developers are looking for? Do we really want to embrace all of this complexity, or is this what we are looking for, in a sense? We simply want an abstraction that says, publish a message to a certain topic. And all of the other things we just saw, maybe we can find a way to, if not completely hide away, at least extract from our set of responsibilities when we should focus on our code, publishing a certain message. And this, resolving these issues, is where you'll find Dapr entering the picture and promising a set of supportive features that we can utilize to accomplish this. So here is an obligatory overview picture of Dapr. On top, you have application code. Again, your application services that make up your distributed application. You can write them in any language, framework, as you see fit. But in order to take advantage of the capabilities that Dapr provides, you communicate through HTTP and/or gRPC with a separate runtime, an actual separate process, which is the Dapr runtime. And this runtime, as you can see, offers a set of building blocks, 4 common capabilities that are closely application related. We just saw messaging. So there is a building block in Dapr that says you can utilize me for PubSub. You can utilize service invocation if you need to speak or target, communicate with a service from another service. You can use state management if you need to store session information or a lot of other things that your application needs to write and read. And then you have more specialized building blocks like distributed locks. Secrets and configuration are pretty much what every distributed application needs. We need to get secrets and configuration into our apps. So this runtime encompasses all of that. And you can utilize, again, these building blocks through HTTP and gRPC. And you can then deploy your application services utilizing this Dapr feature set, potentially where you need them to run in a cloud-native environment like Kubernetes, VMs, on-prem, and so forth. Sometimes I get the question, or I often get the question, how does Dapr overlap with a service mesh? Short answer, does it overlap? Yes. Can they coexist? Also yes. There's a little bit more to go into when it comes to Dapr and service meshes. I encourage you to go to that link on the Dapr documentation. It has a very good explanation of some of the aspects, but they go hand in hand if you want them to. So these building blocks, if we were to see them illustrated in a different way, we can go to this image. Again, for those in the back, it might be a little hard to see, but this is a map of common patterns that you'll find in a book by Chris Richardson. And in this blog article, they have put the Dapr logo on top of the common microservices patterns that Dapr supports. For example, you will find what we just talked about, messaging is a pattern that microservices utilize. Dapr supports that. Dapr supports configuration, secrets. Some things it doesn't support. For example, on the top there you see event sourcing. We'll see how we can add support for event sourcing in a custom way later on. So if you have this map of patterns for microservices, you can easily see how they map onto Dapr building blocks. So if you building a distributed application with these services, you need to embrace or implement common patterns, you can see how Dapr will support you in that effort. So let's look a little bit more about building blocks. So building blocks are not actual things in themselves, they're just standardized APIs. So Dapr formally declares that there is a building block called PubSub. And the API, the way you interact with it, is also defined, as are certain semantics and guarantees. So at least once delivery, what the message format is, how you route these messages, and so forth. All of this is specified in the building block. But that's just the interface, if you will. The actual implementation of the building block of this API is what components are. So components are the actual things that support a building block in all these semantics, and they will handle the interfacing with cloud services. In this case, we have a component that supports PubSub via SNS and SQS. So if we were to use this component underneath the building block that we as application developers utilize in our code, that would be the setup we would get. Note, the topics and the queues should not be thought of as being automatically created by this component. There is still a provisioning part that you need to take care of, or rather, hopefully, platform engineers can help you with, so they don't get just instantiated on AWS. Unfortunately, actually in this case it does, but for production, you turn that off, so you need to manually explicitly create these resources that the component will interact with that supports your application code. So, we have this, and if we look a little bit closer into the Kubernetes sort of map with Dapr included, we'll see that in your pod, where your application service container runs, you will have Dapr included as a sidecar injected. And again, HTTP, gRPC communication between the service and the sidecar in turn communicates with AWS via this component, the implementation of the building block, for example, PubSub. And so you have sort of a control plane for Dapr as well in your cluster, because there are a number of things that need to be controlled when you have a number of pods with sidecars injected. Again, Dapr is only concerned with one cluster, what happens inside one cluster. So there is no, by default, inter-cluster communication going on, just to make a note of that. Also, just as a note, these components are not separate processes, not separate pods in your Kubernetes cluster. They are actually built into the Dapr binary by default. Sometimes that's hard for us as developers if we want to extend Dapr in certain ways, so we'll see how we can get around that later. And if you want to manage multiple clusters with Dapr installed, which you sometimes will have to do, there are tools to help you with that. The commercial entity backing Dapr, called Diagrid, offer a very good tool for this called Conductor, which I can talk more about after the talk. So let's go back to the original example and see what the Dapr equivalent looks like. On the right, this is where you as application developers should be concerned. So we have extracted everything AWS related, and now we're using just the Dapr client, the Dapr SDK, and only that, with the PubSub building block to publish a message, in this case just a payment ID, to a certain topic, confirmed, to the PubSub component. And that's it. This is the abstraction we were looking for. Now, the magic doesn't simply wire itself up. We need to do something else to complete this implementation. So you have some manifest on the left, which is this component that you need to apply to your Kubernetes cluster so we can publish to it. And it can in turn publish to AWS. But you see that we have specified here the region inside of this manifest. That's a vital configuration part that we have now excluded from our code. And there will be other things that go into this component as well. Hopefully, again, you as developers do not apply this yourselves. We'll see later during provisioning that this could be handled for you if you request it by the platform team. And you can see the actual publish code gets translated into a simple REST call to our sidecar. So you can see what that looks like below. Final thing that I want to mention is that every application service in Dapr gets an ID, in this example called payment processor. We can use this to limit what application service can do with regards to components. So here we're saying this payment processor, this application service can publish, but only to a certain topic. Now this is sort of an access control list, right? But the cool part here is that this access control list, you can switch out the actual component that we're using, AWS, SNS, for Kafka. But the same access control list could be used for Kafka as well. We now have a portable way, independent of the actual broker we're using, the message broker, and set access control list for it. So we can reuse those policies if we want to. Just by switching out the component implementations, suddenly we're using Kafka, but the application ID is durable, and we can use it to continue limiting the scope of publishing for this particular payment processor. It's a small thing, maybe, in the grand scheme of things, but it's very useful when you get to actual deploying Dapr. All right. Let's look at another popular building block, which is service invocation, to go through that quickly. So you have one service called customer wanting to interact with another service called checkout. Usually, if you wanted to communicate between customer and checkout, customer would construct a URL, HTTP, and the name of the checkout service to post something. Here, we're using the name of the service, checkout, but we're indirectly calling it via Dapr, as you can see in the first REST request there. Now, Dapr will use whatever DNS capability it can find in the environment it's deployed in. For Kubernetes, it's standard kubedns. The sidecar will call the target or remote sidecar, perhaps encrypted using MTLS. And then the request will be posted to checkout, and it will need to listen, as you can see, on a post/order endpoint to receive the request from customer. And if you want to, we can turn on automatic observability via OpenTelemetry, so we can get all kinds of information, metrics, distributed traces, etc. And also here you can apply access control policies, resiliency policies in a standardized, portable way. So all of this, if we summarize it, we now get, in a sense, complete application portability. We already had it for our compute part. You can put or deploy your Docker image into any Kubernetes environment, have it run there, independent of the cloud vendor. But you were not as lucky previously when it came to actually integrating with specific services that a cloud vendor could offer. Now you have a portable way to do that as well. So portability for both compute, your workloads, and the integration points and needs that you have. Which means that if you need to do any type of switching between products, underlying infrastructure, you minimize the costs, hopefully, using Dapr. As we saw, we can replace the version and the actual underlying message broker if we want to without affecting our application code. There is some modification to that statement, which I'll make later. But when you're building out your architecture, you now have common building blocks that you can use. You don't have to go down to, hopefully, a much custom code that is required if you have these building blocks to utilize over time. Again, policy is the same thing, with just a way to portably construct access control lists. The same goes for resiliency policies. Your skills, hopefully, once you learn Dapr, you can apply them in many different projects and endeavors. So there is some sense of Reusability of your knowledge there as well, minimizing your mental switching costs, perhaps. And I cannot emphasize this enough, you don't have to buy into Dapr completely. You choose the building blocks that make sense for you. Hopefully they cover enough of your requirements moving forward. So for example, should you have a legacy system, a big monolith, you're trying to apply the strangler pattern to extract certain features into their own application services, each service can then be a candidate for Dapr and the building blocks that you see fit. Very important point. Okay, so how do we actually work with Dapr in practice? As an example, I want to use a bike rental service. And again, apologies if not entirely clear picture-wise for those in the back. But this is supposed to be a domain model using the event modeling technique for picking up a bike at the station. The blue stickies are commands. They express intent to change the state of a system. The yellow stickies represent events or state transitions. And the green ones are read models or views of system state. And this shows how your system changes state over time as your user progresses through this particular business flow of picking up a bike. So I'm going to go through them, not all of them, but you see that these slices that make up our business flow are good candidates for aligning with building blocks in Dapr. So we take the first one. There you can imagine that I'm entering in my credential at the station where there is a panel, and it sends some information, including maybe my credentials, to an API backend. And this API backend then sends a request to bike management. In this domain model, bike management constitutes a capability in our system for managing bikes. It could then be one or more application services. At this point, it's not really that important, but what is important is that our API backend sends a request bike, via Dapr service invocation to bike management to record the fact that a bike has now been requested by the customer. So we see one building block, service invocation, being used in this slice, and bike management needs to use state management to store this fact that a bike has now been requested. So we see how these two blocks align with this slice. Next, we have two slices that have to do with reading state. Again, a selector that needs to select a bike for me needs information about available bikes. So you can use state management to read that from wherever store that has this information. And the bike request that just came in Dapr will now combine state management with pub/sub to arrive at a transactional outbox. So there is a request being made, it will be recorded, but at the same time, anatomically, we'll also publish a message to the selector. And this selector has now all the information it needs to move on to the fourth slice, basically unlocking the bike. And it does so, there's again pub/sub involved to trigger a workflow. There's a little bit of trickiness going on when I want to pick up the bike when it's been unlocked, because I have a time period. There's 60 seconds duration before it gets relocked unless I pick it up. It's a bit hard to describe maybe, or just code straightforwardly, but Dapr provides another building block, which is really interesting, called Dapr Workflow. It can use your standard building blocks and compose them together to implement a workflow for when a bike has been unlocked. There's another building block I also want to explicitly mention called bindings. So if a bike is unlocked, how does that happen? We have to tell the station subsystem or core system, to release the bike from the slot and turn on a light that says green. So we can use bindings to interface with external systems. That's very interesting, which I'll go into more detail shortly. The rest, hopefully, is more or less self-explanatory. The workflow ends when I have hopefully picked up the bike, or if the timer runs out. But hopefully, you can see we can start to reason about our system architecture using Dapr building blocks, and maybe a few of our own that I haven't added, with these slices. So we can go directly from domain understanding to the start of a system architecture. A few words about the Dapr workflow part. You have a workflow engine that you can use to write workflows in code. The durable execution part is interesting because should something crash or you have made some progress in the workflow, you can resume where you left off. And you can use certain patterns, standard patterns, in your workflow in an easy way. So quickly, this unlocking part or workflow that I showed in the domain model, if we start by saying to the renter, your bike has now been unlocked, that's an activity, and it will use what's called an output binding to tell me, maybe through a push notification, or show me in the panel that your bike has now been requested. You can find it at slot 16. This workflow will now wait for the bike to be picked up, an external event, and if it gets the event in time, it will then use state management to record this fact in some store. If I'm unlucky, it do not pick up my bike, the timer will fire and it will relock the bike again at the station and we end the workflow. And it maps pretty well to what you might think you would see in code. You describe your workflow, your activities, you compose them together, and you're good to go, more or less. Very exciting about using this workflow engine, particularly in Dapr. And that's a standard microservices pattern. So you might have heard of the term Saga instead. But it's something, again, that Dapr provides for you should you have a need for it. Okay. Sometimes there isn't a building block for everything. I mentioned that Dapr might cover a lot of things, but not everything. So sometimes you need to think about going your own way to some extent. Here, I've had a need to work with event stores. So if I want to do what's called event sourcing, I want to take those yellow stickies that you saw in the domain model, and I want to store them explicitly as a source of truth for my system. I can utilize an event store, where I can store these events natively in sequence. Different from message brokers or event brokers. Event stores store events specifically. There isn't a building block for this to communicate with event stores or do event sourcing. How do we get the building block? Well, there is a process for it, but it takes a long time. We can't wait for that, so we can use these bindings, that building block, to create our own communication path with an external system, such as an event store. And we can register this as a pluggable component, a separate process that tells Dapr, I exist, and applications can now use me to interact or interface with event store. So how does this look? Normally in event stores, you append and read the events directly. We're going to use another pattern in microservices context called CQRS. Maybe you're familiar with it. In this event model, we'll now think of these release bike and bike released types of messages as actual things that we will use in our system. So you see we have removed service invocation that we previously used. And now when a bike gets picked up, the station will actually send a command, release bike, to a target command handler somewhere where the command will be processed, an event will be generated, the bike released event. It will be stored in the event store. We'll build up the available bikes view from it that the selector can query. So commands and events, they're not just things in our domain model anymore. They're actual things we use to communicate between different parts of our system. We're using the Dapr bindings component, so we're saying if a command is sent out, it will be sent via Dapr to a specific component that we implement that will talk to the event store that I've chosen for this example, that I've worked with a lot, called Axon. So Axon is a technology stack which incorporates support for event sourcing and this type of messaging. So we will, via Dapr, interface with Axon, that event store, and it will route my command to a command handler. That could be another Dapr service, for all we know, but we could implement it as such. And again, the command gets processed, we apply and generate an event, it gets stored in Axon server, and we can query the resulting view, available bikes, through a query message. So There are a bit of things going on here, but the main part to take away from this slide is that Dapr gives us the option of interfacing with external systems that it doesn't have building blocks for, but that we can build our own components for. And this is how we would interact with an event store, which has been a need of mine. So we will call this component a message bus. And looking a little bit more closely at that component that we're building ourselves. So in our app, we would write binding.send. We would say, send now something to this component called message bus. There's a command that I want you to handle. So we'll invoke an operation that the command supports called send command, and we'll simply provide the actual command that we want to send. Dapr will via gRPC communicate with our component, again a separate process running in Kubernetes, and that component knows how to speak to the event store. But we have to apply some YAML to make sure that that component actually gets instantiated. So hopefully you can see that when Dapr doesn't cover your needs, there is some things that you need to do on your own that might be trivial all the way to non-trivial, depending on your own background and knowledge and skills, etc. But this would be, I think, a very illustrative case in terms of the steps involved for interfacing with an external system, in this case, an event store. I want to just stick around a little bit more when it comes to messaging. Messaging is not just pub/sub, as we have seen. There are different types of messages. Events are one kind. There are commands and there are queries, as we have seen. Now, if you're using messaging, asynchronous communication, for most of the interaction, if not all of your interactions in your system, there are some interesting properties that come into play. So, when you're building a new system, say, you might not always want to go distributed all the way from the outset. You might say, let's build a simple version of our system first. Let's build a monolith, modular, of course, but we will use messages to communicate between the different parts of this modular monolith. Commands, events, and queries. As time passes, you might see that certain parts of this monolith cannot be extracted. They need to be their own application services. Then you can simply extract them. Why? Because messages are routed to a destination. The caller, the sender of a message, doesn't know where it ends up. When you publish a message, when you publish an event, you don't really know who the consumer is. That's the whole point. So using messaging, you can extract components the way you need them to be extracted and scale up as needed. So we call this location transparency. A very nice feature of messaging. However, Dapr is distributed. It's in the very name. It means that every type of communication goes out of your application process outside to the network, traverses a network boundary. So it makes it a bit hard to build systems that are message-driven with Dapr if you don't account for it. I'm not going to spend too much time on this, but you might have to introduce specific abstractions along with Dapr to enable, for example, location transparency. So in this case, we have to build what's called a command bus to say, sometimes the command handler that will process our command is in the very same process as the rest of our system, but sometimes it needs to go out to the network. We, as sender of the command, don't really want to know where it goes. It just needs to be handled. So we need, again, something else on top of Dapr to route commands and, in general, messages in an intelligent way. And again, this is not so much about extending Dapr, but you will run into cases with Dapr where a building block doesn't cover all your bases. So you might have an application service that uses the building block state management to write and read state. In this case, the component would be a PostgreSQL database on AWS. But then suddenly you have a need to execute raw SQL queries against that database. The state management building block doesn't support that. doesn't know what SQL is. And there is no SQL building block. I don't even know that would be meaningful. But you need to do some raw SQL query. What's your option? Well, it will become a dependency. You will have to add something else to your code that does this explicitly, but at least you can isolate that part. So you might introduce another service. Hopefully you can limit the SQL-related functionality to just that service. You can use maybe Dapr servicification between A and B to execute the query. But again, you have the problem with a specific client library version, etc. But maybe you can limit the scope of that impact on your system. But dependencies of this kind will be, unavoidable. But you can work around them, hopefully, to a good result. All of this to say, extending Dapr, these types of dependencies. A famous architect said the following: you can build abstraction layers, which is what Dapr is. It's a set of standard APIs, right? With supporting component implementations. You can't hide the underlying characteristics of your platform and your infrastructure. They will surface. You will have to account for them, and they might impact your application behavior in subtle ways or not so subtle sometimes. Example, I can use state management. I can read and write state to DynamoDB. There's a component for it. I can also do it to a PostgreSQL database. Those differ widely in terms of scaling capacity, of latency, pricing, right? So consistency guarantees. So just the fact that you're using a building block called state management, choosing the actual component might have some behavioral impact on your application. So if you're an application team, you have a certain budget, you can just relaxing with this abstraction layer called Dapr doesn't fulfill everything that you need it to do. You will notice the underlying characteristics as you work with Dapr. You need to bring that consideration into your planning. So that's one of the very critical parts I want to convey to you in this talk. In some of the final pieces of this talk, I want to go into how Dapr relates to platform engineering. Remember, you're using this abstraction layer called Dapr, using supporting components, but the actual resources do not get automatically created for you. You need to provision your DynamoDB table, your SQL database, etc. So what tools do you use for that? Who does it? If we start with tooling, there are a number of such tools to choose from. I am a aficionado of Crossplane, recent aficionado. I like the way you can declare abstractions for application teams that they can apply to a cluster. In this case, a platform team, together with application teams, have defined what a database is. So I can, as an application developer, say, I want a database. I want it to run, in this case, on AWS, and it should be a small instance, whatever that means. That will be created, provisioned for me on AWS. So if I want to use the building block for state management, and Postgres is what I have in mind for a supporting component, this database abstraction, when I apply it, would provision this database for me. But there's a little piece missing. So if I apply that YAML you just saw, the cross-plane plane will take care of that for me. It will instantiate what's called a composition. We can leave that term aside for now. All it does is it gathers together everything required on AWS in terms of resources, and it gives me the database. It also creates credentials for me, and it populates the Dapr component YAML with it. So that cross-plane stuff in the composition, together with the Dapr component, that manifest, will then be applied together. And my app is now ready to, via Dapr and this Dapr component, read and write state on AWS. Again, who is responsible for what? Just naming my application. Is it me as an application developer who decides that, together with the platform team? Naming of topics. Again, this is a wider issue that this talk cannot go into for obvious reasons, because we don't have enough time, but this is just the technical wiring of it all. There is a negotiation that needs to takes place between the application team and the platform team. But this is how you would wire it up in a sense. Again, this is still quite low level, but there are other tools that raise the bar additionally. So if you use something like Cratix, you can have one manifest, more or less, that says, not only will I install Dapr for you in your cluster, I'll also add this cross-plane thing you speak of. I will deploy your application, your workloads, as well as the database you want. And when it's all applied, eventually it will be up and running for you in the environment that you desire. So Cratix gives you a capability to sort of describe everything you need for your application finally to run on a higher level. This could then use, for example, Crosslane behind the scenes, but I like that there are tools now that go all the way to give us as application developers a simple, perhaps just one manifest to rule them all. A bit more detail into this, but hopefully you get the sense of what we can accomplish using a tool such as this. This is important. If I choose to add a building block to my application and I need an additional infrastructure piece, they need to be in sync. Otherwise, I'll probably end up in a state that I don't want to be in. So, I want to end with some notes about what developers actually think about this and whether you should adopt Dapr and how you should think about it. So, if you just look on the left, you have building blocks and their popularity among developers who have adopted Dapr. There's hopefully not too much surprise in PubSub being very popular, service invocation and state management close second and third. On the right, you have why people like Dapr. The one that surprises me when I saw this was the second reason. No code changes when swapping components. For example, if we move from Redis to Kafka for PubSub. Now, does this happen often? Probably not. It's nice that you're able to do this. That's the whole promise of Dapr. But I'm struggling with whether this is a nice to have or it actually was something that I used. But again, that's what Dapr offers, so I guess that's what people take to when they look at Dapr. So hopefully you get a sense of what people actually experience and some of the outcomes when adopting Dapr. So, we get with Dapr a platform and language agnostic way of building distributed application and associated services, which means that we get true, in a sense, application portability for our compute and for our integration needs. By its very nature, we separate application code from underlying infrastructure. But that's not the whole story. As we just saw, the provisioning part, the platform aspect, still remains. And Dapr is, again, not one big buffet from which you have to sample everything. You choose the building blocks, and the same mindset you can apply whether it's a migration scenario or a greenfield. Pick the parts of your system where a certain set of building blocks makes sense. And you can simply add more later. So here's the $64,000 question: should you adopt Dapr or not? I can only give you like a signal, things to look for. If you're, say, building out a new system, and a large, I would say very large part of your system, and the business logic you have to implement, could be done through building blocks alone, that's a very good sign. It means that these are quite expressive and broad enough to cover most of your needs. And if you also weigh it to the management investment you have to do, you have to manage your Dapr installation in Kubernetes. You have to invest in platform capabilities, etc. If you can keep that cost down or to a reasonable degree compared to what you save and how effective you can be with Dapr when you actually build your applications with these building blocks, I think you might have a reason to at least look into it more closely. And if you're interested in having that discussion more in depth, I'd be happy to take your call. So please reach out to me if you're having questions about adopting Dapr and you need more insights into the things we just discussed. Thank you very much. A question in the back. We have some time for questions, right?
Okay, thank you, Marc, for the talk. Very interesting. I just had a question, like, what were like the most, I don't know, interesting applications adoptions of Dapr in production that you have seen, and like how were the architectures? Yeah.
I'll answer that on a more general level, but that cuts across the project I've seen it applied. Most developers, and this is not a skill issue, most developers, including myself, we have a hard time building distributed systems. That's just a fact. The patterns alone that you saw, they can take quite some time to dig through, and the knowledge on how to apply them and when, it's not a non-trivial, it's not a trivial exercise. So, for teams that are just being exposed to this, maybe they are currently with a legacy system and they need to become productive quite rapidly and have an easy path to understanding what it actually means to build a distributed system, this is where Dapr shines. It takes away a lot of the magical mysteries of distributed systems, make it a little more easy to crunch and actually implement and put into production. And especially takes away the nitty-gritty details of configuration, as we've seen. So that's where I've seen Dapr have success. From only speaking now from an application developer point of view, you simply feel and you are actually more productive as a developer with Dapr. And as you saw, the most common building blocks, those are also the ones that I've seen utilized mostly. Though they cover many types of scenarios for messaging, state management, and I'm beginning to see more about the workflow part as well. Hopefully that answered your question. Thank you. Any other musings, questions? Again, the promise, I would say, largely is the efficiency gains as developers. And this is mostly where I want to park this talk for application developers on what you can get out of it. So hopefully you maybe got some inspiration, but requisite insight in what it would take to work with Dapr. Yeah? One more question maybe? Or if not, again, reach out to me if you need to, want to. I think we're good. All right, thank you.